So we've got first up Justin Anderson, who's going to talk about the Hypercat Alliance, and it's really important, I think, to understand that there's a relationship going on between Australia and the rest of the world in terms of IoT, and one of the leading players, or one of the leading platforms, I guess, if that's a way to describe it, is the Hypercat. So please welcome our first guest. Thank you.
Thanks very much. So I'm over in Australia for 6 months to engage on two counts. One is I'm working with KPMG, helping to launch their IoT practice, which in fact is the first IoT practice launched by any Big Four company over in Australia. And the firm has invested heavily to be able to bring together some great talent there. But my other hat is as the director of the Hypercat Alliance, which in fact is an initiative, strangely enough, that was started about 5 years ago between Rahim, who spoke this morning, and myself, in the University of Surrey. And at the time, it was just an idea. But what it's grown into is a true interoperable IoT ecosystem. So I want to share some stories about how that came to be and give you some insights into what the UK has been doing to allow you to understand potentially some of the opportunities that IoT could present in Australia. We are definitely slightly ahead in the UK, as much as anything, because the government has invested very heavily through Innovate UK into a number of early IoT projects, and that innovation has been fueled with further investment. And Hypercat has effectively been the beneficiary now of about $100 million worth of investment into different programs that it has had to be a part of for one reason or another that I'll explain. Actually, I'm not sure which of these buttons I'm supposed to be pressing. The green one there, yeah. So what's it all about? I mean, at a very, very high level, context around the Internet of Things. What have we been trying to do? Two simple things. One is optimizing resources, and the other is just taking away some of the friction in our day-to-day lives. And the approach that we've taken is something which is easy to say, collaborative innovation, bringing people together to create something new. A new idea comes through discussions. But the reality is that it's much more difficult to do, and it's certainly difficult to do at scale. How do you achieve that? Well, there's a few lessons that I've learned through this process of building up what is effectively now over 2,000 different organizations. The first thing is that you have to get alignment. That's not 2,000 organizations working together at the same time. Effectively, I've been involved with various different consortia of different sizes that have had to be aligned to focus on particular problems. So at any point in time that you're involved in any kind of consortia, alignment is absolutely key. If you haven't got everybody's interests focused in the same direction, you're not going to get there. The second thing, of course, is that as you create this new innovation, you have to be very careful about what is created and how you manage that new IP that comes about. And you have to be very clear up front that you have the right framework and the right governance around any programs to ensure that what comes out of it is fully understood, how that is going to be owned, how it's going to be commercialized, monetized, and taken out to market. Who's going to do that? So there's quite a lot of work that needs to be done before you really get into the programs themselves and be successful with this sort of initiative. So Hypercat in a nutshell. As I said, we started working out with the University of Surrey, one of the key collaborators in a program that's effectively brought together some new joint offerings, tapping into the resources at the university and the IoT department that they have there that sits alongside their 5G department. And bringing in some of the major players that include organizations like Cisco and Intel and IBM, ARM and BT and KPMG, in order to be able to create new joint offerings. And I'll share some of what came out of that program a little bit later on. But the key was to then be able to create these test beds in order to prove the value and ensure that from these early stage demonstrators, we could really understand what the value of each individual demonstration was and how that might be further commercialized. And throughout every program we ran was always a particular stream focused on how you scale this at the end. And obviously that's the key, is to make sure that you can align your demonstrators with the future of value that you're trying to create, understand that, work with analysts, work with the likes of Gartner and Forrester and others to be able to start to tease this out independently, work with strategic partners that can start to take some of these solutions out to market. But ultimately what's key is that there's a sort of core driving force that gives everybody the impetus to actually drive something forward. And there's nothing like having a very large sum of money sitting somewhere that can align interests. And we were fortunate to be able to get involved with Boris Johnson's London Infrastructure Investment Programme, which effectively is a £1.3 trillion investment into London to allow it to grow to support the future urbanisation that they're projecting. And of course, that then creates the value for all stakeholders off the back of it. So I want to just look at where IoT is today. We're effectively sitting at Gartner's peak of inflated expectations. Okay, this is a place that there's only one place to go after you sit there, and that's to go down into the trough of disillusionment. Why will that happen? There's a number of reasons that we're going to see some of the luster come off IoT potentially over this next short period of time. There's likely to be some kind of cybersecurity incident. We've already seen massive denial of service attacks that start to cripple parts of the internet, but this is going to continue. But one of the largest threats that we see right now on the internet is ransomware. And I heard a distressing story last week about a hotel that effectively was hacked, and the rooms were locked by the hacker from some remote site. But they also received a ransomware demand. Pay up, or your guests don't get out of their rooms. It's a very simple way of being able to extract money, and this will happen increasingly, and the IoT, if it's not secure by design from the start, will lead to more incidents. So security is absolutely key. But if we look forward 5 to 10 years, we will have got through this trough of disillusionment into that plateau of productivity, as they call it. So we are on this journey at the moment where it's going to be a little bit bumpy, but certainly the direction of travel that we can see is value that has been estimated to be in the trillions of dollars of economic value by many analysts. In fact, there seems to be a battle for who's got the biggest numbers. All the numbers around IoT are billions and trillions. Effectively, if we look at why this, what's the driver behind this, we're looking at a couple of key things. Efficiency and experience, and the change there will change the business models. But there are problems today. I've mentioned security, but understanding what standards need to be put in place to bring together these new stacks is key. There is a distinct lack of skills and understanding of how to put things together. That will slow things down. There's a complex vendor landscape with people saying different things or making different claims. The reality is that we're still working with relatively immature technologies that have just started to get going. And some of the issues around ownership and governance will slow things down. But if we look forward a little bit to 2020, it's expected that we will see 54 exabytes of data coming as a result of IoT. Has anybody got any idea of what that represents? It's a huge number. That's 54 followed by 18 zeros. And to try and visualize this, if every byte was a grain of rice, this would be the equivalent to 3 meters thick of rice across the whole of India. Okay, it just gives you a sort of sense of what that looks like. And that's coming from a number of different systems. The main area we're seeing at the moment is automotive systems. Modern cars are being built with up to 2,000 sensors in them, preparing them for that next stage of the automotive transformation. But we also see a number of different types of sensors that are coming to market, and this long tail that will continue to just bring all sorts of different products out there. But certainly, again, the automotive subsystems of lighting and cameras sitting up there at the top end. But I want to just give you a quick history lesson. Looking back on the technology world, I don't know if anybody here, probably there's somebody here that was working with IBM in the 60s or 70s. They were dominant. They did everything. They provided everything from the field service through to the equipment. But bit by bit through the 80s and 90s, the structure of the computer industry changed and it was sliced up. So you've got specialist capabilities from lots of different companies. And that has just continued through to today. And the reason for that is that if you look at Clayton Christensen's work on innovation, he looks at the interdependent architectures that in the early stages can beat the competitors with their functionality. They're strong and they're bold and they can go out there and they can drive new innovation. But over time, the modular architectures that allow specialist components to be put together can start to beat their competitors with speed and responsiveness and customization. So interoperability, effectively tying together different components, is critical. And McKinsey suggests, in fact, that this will represent about 40% of the value of IoT, the economic value of IoT. So that's a big chunk that needs to be addressed. And how do you do that? Of course, what you need to do to get everybody able to connect through their components is to get a level of agreement, which is a challenge. Which is why you then need to bring in the standards bodies to start to understand how you might create the appropriate standards around this space and address this thorny challenge of getting every component to talk to each other. I never imagined I was going to spend quite so much of my life involved in standards. I always thought that they represented rather a dull thing, sitting around tables trying to reach agreement. Actually, they are extraordinarily exciting things, because what you find is that some of the brightest minds come together to agree what best looks like. And through that process, the discussions can be quite fascinating. So we brought in the BSI and got them to work through a framework around this particular problem, overlaid on top of the program that the British government was funding, to be able to address this thorny challenge of interoperability. What you see behind us here are 3 standard technology stacks for IoT, broken down with devices, gateways, cloud services, and clients. And Hypercat just sits there between the cloud services and the clients, allowing different clients to talk to different systems. And it does that, essentially, by allowing you to create the catalogs of data and reference the ontologies that sit behind those data models so that it's easy and machine readable for another system to come along and ask the simple question, what have you got, with a response that can be understood with a common language that allows you then to avoid the amount of developer work that would need to be done to go and research the APIs, understand the ontologies, and break that down further. So this is now being tested at scale in Manchester at their CityVerve program, which addresses a very broad range of different use cases. It's one of the most advanced smart city programs in the world, backed by the UK government. So Hypercat is currently being tested at scale. This is being led primarily by Cisco. But as well as being able to bring together different organizations, it's important to be able to make sure that the standards bodies themselves are all able to agree. And that itself is a challenge. How do you ensure that different standards are going to line up? Because there's no point ending up with 20 different standards. So Hypercat is building bridges between standards development organizations as well. So we work with the BSI and the W3C to be able to connect their work, which allows you to start to think about how the nature of the Internet of Things will be embedded inside the Web of Things, which is Tim Berners-Lee's current driver for the W3C, one of the key pillars going into the future. How do we take the web itself forward and ensure that the structure of the things that we're trying to represent in the real world, in this virtual world that we interface with via the web, is able to leverage the understanding that's there around the way that data comes together, the relationships of data, or the semantic web, as Tim refers to it. But Hypercat sits as a part of a portfolio of standards that the BSI is taking through to ISO levels that looks on one side at the built environment with BIM, and on the other side with a range of PASs looking at everything from the terminology and the reference frameworks for smart cities, and just sits in there at the middle, being able to ensure that there is a way of connecting everything up to the real world through the IoT. Hypercat has also been involved with moving forward on a number of different fronts with what we call the spearhead projects, where we've got different consortia working together to solve various different challenges across a very wide range of different use cases. But the key thing is not so much about the fact that the use cases themselves are critical. What's key is that each of those different use cases needs to be able to talk to each other. They become discrete components and bring together components and services to create a smart system that then can be connected together. And once you start to allow all of those systems to plug into what is effectively a value web, you can create a whole new layer of innovation. So if we just take an example of some everyday objects that we find around us and overlay that with some interoperable systems, I'll give you a second to read. Those are the sorts of sensors we see already in vehicles and on machines. As you allow those to all talk to each other, what you have is a platform for innovation that lets you combine different data sets in a way that lets you create new use cases that you couldn't if you've got sensors that are sitting in silos, managed through to a data system independently. So that's the key to it. And we've then taken these ideas and we've started to work with some of the largest regeneration projects in Europe, and we're having discussions over here. The Old Oak Park Royal in London is the largest regeneration in Europe. They've got they're the intersection between High Speed 2 and Crossrail, which are two major new rail links, and that will create a new platform, a station of 250,000 passengers a day and 65,000 new jobs. Actually, quite a similar sort of size to Fisherman's Bend, and some of the similar sorts of challenges that the state here is trying to grapple with as it thinks about what we've got to do with Fisherman's Bend that's going to make it smart. So we were brought in to work on the smart strategy to support the local planning policy, and as a result, spent time looking at all of the different assets that sat within this world and understood all of the different layers that needed to be put together in order to create the right sort of infrastructure that sat underneath it. So I've already talked about cars, 2,000 different sensors in modern vehicles. The building that I'm working in at the moment in Barangaroo, KPMG's building, has 2 million events a day coming from sensors, 50,000 sensors embedded into the fabric of the buildings. Obviously, the developers are starting to really understand how to put this together. Within a city, I think what's an interesting asset that's one that is starting to come together, and I was up in Newcastle recently, they got 40 new smart poles that are being put out, and the new lights, so the humble lamppost now is able to measure air quality and provide mesh light, Wi-Fi and LED lighting, of course, and traffic and pedestrian sensors, and understand how to communicate with passers-by through the digital signage, which will increasingly become Minority Report style, where that data will actually be able to change depending on the people that are around it. We've got potential for the posts themselves to talk to you, concealed speakers sitting in there, water detection or seismic monitors, understanding what's going on in the environment, potentially being able to support emergencies or detect various different types of noise around. So what's going on with Hypercat now in Australia? The Honourable Angus Taylor recently launched it with Nick McInnes, British Consul General, as an Anglo-Australian collaboration in smart cities. And as a result of that, we've also been fortunate to work with two important Australian organisations in this space, Iota. John Stanton is going to be talking shortly. We are now working with Iota to help them with a new work stream around platforms and interoperability to help convene the community over here together to really start to tease this apart, understand it in different ways. And ASCA, which is the Australian Smart Communities Association, which is endorsing it for its use in cities. It currently has about 130 councils around Australia. And so now what's important is that we have both that early stage catalyst of ideas that have come together, scaled up, where we've got references of large-scale city deployments, and now, most importantly, the city's waking up and saying, this sounds like a good idea. Let's see how this might work in our city. Thank you very much. Hopefully, I'm within time, and I think I might have made up a little bit even.
Please thank Justin for, well done, Justin. Thank you very much for getting us almost back on time.